So student, today we are going to see the complex variable. So what is the complex variable? The derivative, that is the analytic function. Analytic function means what? Also the Cauchy-Riemann equations, that is C.R. equation. So let's start. Complex variable. So in the complex variable, first we see the number of the form z equal to x plus iy, where x and y are the real numbers and I is imaginary unit. So what is the property of this I? That is the I square equal to minus 1, and when we take a square root, then I will get here I equal to root of minus 1. So normally complex number is denoted by z. Therefore z equal to x plus iy. Then x is called the real part of this complex number z and y is called imaginary part of this complex number z. The real part is denoted by REZ. Therefore, real part of z equal to x in this case, and imaginary IMZ, that is equal to y in this case. So note that if we consider z equal to 2 plus 3i, so what is the real part? 2 and imaginary part is 3. Now polar form of the complex number. If we consider the complex number in the form of r and theta, as we know that is z equal to x plus iy, right? And by this figure, if we find the value of cos theta is x by r and sin theta is y by r, and by using this I will get here z equal to r in bracket cos theta plus I sin theta. From this, if we find out x equal to r cos theta, y equal to r sin theta, we can find r equal to under root of x square plus y square, and it is known as modulus or magnitude of the complex number z, and theta, that is equal to tan inverse y by x, is called argument or amplitude of the complex number z equal to x plus iy. Now actually function of the complex variable means what? If x and y are real variables, then z equal to x plus iy is a complex variable. If for each value of complex variable z in the given region R, there exist one or more values of another variable w, so that w I will define by u plus iv. Then w is called a function of complex variable z, and it is denoted by w equal to f of z, and that is equal to, if we write this, it is u plus iv, because w equal to u plus iv, and that is equal to u is a function of xy, v is a function of xy. For example, if we consider w equal to 1 by z, so what is z? Z is what? X plus iy, and you know how to write it. It is x minus iy upon x square plus y square. And if we compare, that is w means what? U plus iv, and that is equal to x upon x square plus y square. If we simplify this one, and that is minus I y upon x square plus y square. So you can observe here u equal to x upon x square plus y square and v equal to minus y upon x square plus y square. So this is a function. So function of complex variable, you don't forget. Now just like a real number, the derivative of complex number we can define as if w equal to f of z is a single valued function of the variable z equal to x plus iy, then the derivative of w equal to f of z is defined as dw by dz equal to f dash of z, and that is limit delta z tends to 0 of f of z plus delta z minus f of z upon delta z. As you know, if y equal to f of x, then by the first principle, what is dy by dx? It is a limit h tends to 0, f of x plus h minus f of x upon h. Similarly, in the same manner, I can define here the derivative of f of z. Provided limit exists and has the same value for all different ways in which delta z approaches to 0. This is very important part. Different ways in which delta z approaches 0. Now the analytic function, a single valued function w equal to f of z equal to u plus iv possesses a unique derivative with respect to z at all points in the region R. Then it is said to be analytic function, or you can say regular function. It is also called holomorphic function of z in R. Now here is one theorem. This is very important theorem. The necessary and sufficient condition for the derivative of function w equal to f of z, that is equal to u plus iv, to exist for all values of z in the region R are, there are two conditions. First, w by w x, w by w y, w v by w x and w v by w y. means all partial derivatives of u and v with respect to x and y are continuous functions of xy in the region R. And second, that is delta u by delta x equal to delta v by delta y, and delta u by delta y equal to minus delta v by delta x. In this theorem, the condition this second is known as Cauchy-Riemann's equation, in short C.R.Equations. So what are the C.R.Equations? Delta u by delta x equal to delta v by delta y, and delta u by delta y equal to minus delta v by delta x. So definitely there will be examples on this C.R.Equation in exam. If u and v are real single valued functions of x and y such that delta u by delta x, delta u by delta y, delta v by delta x, delta v by delta y are continuous throughout the region R, then C.R.Equation means Cauchy-Riemann equations delta u by delta x equal to delta v by delta y and delta u by delta y equal to minus delta v by delta x are both necessary and sufficient conditions for the function f of z equal to u plus iv to be analytic in the region R. It means that first condition it is continuous and second it is C.R.Equation. If itself that is continuous, only this condition is necessary and sufficient condition for the function is analytic or not. Now the C.R.Equations in polar form means what? That's Cauchy-Riemann equations in polar coordinates. We can prove it easily, that is Cauchy-Riemann's equation in polar coordinates are delta u by delta r equal to 1 by r delta v by delta theta and delta v by delta r equal to minus 1 by r delta u by delta theta. How we can prove this? Very simple, that is as w equal to f of z, and what is z in the form of now polar r e raised to I theta. What is w? W equal to u plus iv, and then differentiate with respect to r. So left hand side it becomes delta u by delta r plus I delta v by delta r equal to derivative of this with respect to r. So it is e raised to I theta, and with respect to theta, so what is the left hand side? That is equal to, so delta u by delta theta plus I delta v by delta theta equal to f dash r e raised to I theta, and derivative of this with respect to theta again it is r e raised to I theta into I. Just equate these two. So if I multiply this with I r, so what it becomes? It becomes delta u by delta r into I r minus I into I. It is a I square, that is minus 1. So minus r delta v by delta r, and that is equal to f dash of r e raised to I theta into I r e raised to I theta. So you can see this side. So right hand side of both equations are same. Therefore left hand side are also same. And that is why real part of this equation is delta u by delta theta equal to, what is the real part of this equation? It is a minus r delta v by delta r, and imaginary part. So equating real and imaginary parts of both equations, I am getting here delta v by delta theta equal to r delta u by delta r. So by using this I am getting delta u by delta r equal to 1 by r delta v by delta theta, and delta v by delta r equal to minus 1 by r delta u by delta theta. So these are the Cauchy-Riemann's equation, means C.R.Equations in polar form. So you remember these things. Now the harmonic function in Cartesian form. So what is meant by harmonic function? The function which satisfies the Laplace equation is known as harmonic function. So Laplace equation is what? Del square u equal to 0. Means delta square u by delta x square plus delta square u by delta y square equal to 0. Therefore any solution phi of this Laplace equation is known as harmonic function. Note that here, if w equal to f of z and that is equal to u plus iv is analytic function, then it satisfies C.R.Equation. Delta u by delta x equal to delta v by delta y, and delta u by delta y equal to minus delta v by delta x. If w equal to f of z equal to u plus iv is analytic function, then u and v are harmonic function, and these u and v are known as harmonic conjugates of each other. Sometimes we have to find the function f of z in the form of z. Suppose we have a function in the form of x and y, and we want to find in the form of z. Then use this Milne-Thomson's method. What is this method? By this method, you put x equal to z and y equal to 0. Therefore, this f of z equal to u of z0 plus I v of z0. It gives your function f of z in the form of z only. So remember this thing, to express any analytic function in terms of z, use this Milne-Thomson's method. Means put here x equal to z and y equal to 0. If the function f of z is in polar form, it means that it is in the form of r and theta, then you can use Milne-Thomson's method as by substituting r equal to z and theta equal to 0. You will get their f of z in the form of z. Now consider one example. If v equal to 3x square y minus y cube, then find analytic function f of z in terms of z. F of z means what? F of z equal to u plus iv. So w equal to f of z, that is equal to u plus iv. So here v is given, we want to find u. So there may be the question like that, u is given, find the value of v is given, find the value of u plus v, or any relation between u and v is given, find the value of u comma v. Also f of z, once we have value of u and v, we can find f of z in terms of z. So how to solve this type of examples? So if u is given, don't forget here f dash of z equal to w by x plus I w by x, right? Since it is analytic, it satisfies C.R. equation. W by x equal to w by y and w by y equal to minus w by x. So you replace, if suppose u is given, you find w by x and w by y. So in this case, you replace w by x by this, and then you will get values of f of z in terms of u. Then integrate it, will get f of z, and then by Milne-Thomson's method. What is this Milne-Thomson's method? That is x equal to z and y equal to 0. You will get that f of z in terms of z. Similarly, if v is given, then I will find w by x and w by y, and here this you replace by C.R. equation and then substitute these values. So we will get there f dash of z and then integrate again. So we will get f of z, and by Milne-Thomson's method you will get f of z. Here we will see how to solve actually. Given v equal to 3x square y minus y cube. Then differentiate this partially with respect to x. So w by x is what? It is a 3xy. And what is the w by y means with respect to y? It is a 3x square minus 3y. Note that our target is f dash of z equal to w by x plus I w by x. This is our target. Now here v is given. So we have this value. I want to replace this in terms of v. How? So by C.R. equations. Since f of z is analytic, it satisfies C.R. equations. What are the C.R. equations? W by x equal to w by y and w by y equal to minus w by y. Also, f dash of z equal to w by x plus I w by x. So this value we have, I want to replace this. So by C.R. equations, what is w by x? It is a w by y. So therefore, f dash of z equal to w by y plus I w by y. So both value we have. So substitute these values in this equation. So therefore, f dash of z equal to w by y. It is a 3x square minus 3y square plus I w by x. It is a 6xy. By Milne-Thomson's method. What is it? You convert into z. That is, put x equal to z and y equal to 0. Here f dash of z equal to 3z square. This is 0 plus I 0 because y equal to 0. Therefore, f dash of z equal to 3z square. So integrate or integrating both sides, we get. So what is the integration of f dash of z? That is f of z, and that is the integration of 3z square with respect to z. plus integration constant. So I am getting f of z equal to 3 z cube by 3 plus c. So f of z equal to z cube plus c. So this is your f of z. So this is a required f of z, analytic function f of z in terms of z. Sometimes if v is given, so there may be the question that is find corresponding harmonic conjugate, that is u. So how to find u? Actually this is your here final answer for this example. But suppose I want to find u. So what is the z? Z equal to x plus iy, and therefore f of z equal to x plus iy cube plus c. As we know, what is the a plus b cube? It is a cube plus 3a square b plus 3ab square plus b cube. So by using this formula, I can write here f of z equal to x cube plus 3x square iy plus 3x iy square plus iy cube. Note that here I square means minus 1 and I cube means I square into I means minus I. And that is why f of z equal to x cube plus I 3x square y minus 3xy square minus iy cube plus c. And therefore f of z equal to, take a real parts only. So x minus 3xy square and imaginary part only 3x square y minus y cube and plus c here. So what is f of z? F of z is u plus iv equal to x cube minus 3xy square plus I 3x square y minus y cube plus c. So equating real and imaginary parts of both sides. So what we get? What is the real part here? X cube minus 3xy square and v equal to 3x square y minus y cube. So you can observe here, what is a v? 3x square y minus y cube. 3x square y minus y cube. So our answer is correct. So this is verification also. So v is correct means definitely u is correct. Now what about this c? So definitely v is given. It not contains c. So definitely u contains c. So this is your required u also. Now consider the another example. If u equal to 3x square minus 3y square plus 2y, find v such that f of z equal to u plus iv is analytic. Determine f of z in terms of z. So here we want to find v also, corresponding harmonic conjugate you can see. So as per this step, solution is what? What is the given thing here? So given u equal to 3x square minus 3y square plus 2y. So differentiate this with respect to x partially. So I am getting here it is a 6x and dabba u by dabba y equal to minus 6y plus 2. We know f dash of z equal to dabba u by dabba x plus I dabba v by dabba x. So if I consider this is equation number 1 and this is equation number 2. So here we have this value. I want to replace this value. So by C.R. equation I can replace it. Why? Because f of z is an analytic function. Since f of z is analytic, it satisfies C.R. equation. So what are the C.R. equations? Dabba u by dabba x equal to dabba v by dabba y and dabba u by dabba y equal to minus dabba v by dabba x. So here I want to replace this because u we have. So what is dabba v by dabba x here? This minus side, this side, and minus dabba u by dabba y. Using this, in equation 2, we get f dash of z equal to dabba u by dabba x and this dabba v by dabba x, it is a minus I as it is dabba u by dabba y. So now both value we have from equation 1. So use this. So from equation 1, f dash of z equal to dabba u by dabba x, it is a 6x minus I dabba u by dabba y, it is a minus 6y plus 2. Convert into z. So by Milne-Thomson's method, put x equal to z and y equal to 0 and therefore f dash of z equal to 6z minus I 0 plus 2. So f dash of z equal to 6z minus I 2. So integrating both sides, we get integration of f dash of z dz equal to integration of 6z minus I2 dz plus c, integration constant. So what is the integration? 6 z square by 2 minus I2 constant into z plus c. So it is your f of z. So simplify it. I am getting here f of z equal to 3z square minus 2iz plus c. So this is your f of z in terms of z. Now we want to find corresponding harmonic conjugate. It means that now we want to find corresponding harmonic conjugate. It means that u is given, we want to find v. So how to find it? So since what is the z? Z equal to x plus iy. So f of z equal to 3 x plus iy whole square minus 2I, z means x plus iy plus c, and that is why f of z equal to 3 x square plus 2I xy and iy whole square. So what is I square? It is a minus 1. So minus y square minus 2ix, if we multiply inside, minus I into I, it is I square means minus 1. So it will be plus 2y plus c. So f of z means u plus iv. So just collect the real part only, means it not contains I. So 3x square minus y square plus 2y, and now the imaginary parts which contains I, coefficient of I. It is 6xy minus 2x plus c. So equating real and imaginary parts of both sides. Equating real and imaginary parts of both sides, we get u equal to 3x square minus y square plus 2y and v equal to 6xy minus 2x. So what is given here? U equal to 3x square minus 3y square plus 2y. 3x square minus, okay, 3y square, here should be 3. How? If we multiply 3 inside, so I am getting here 3. So u is 3x square minus 3y square plus 2y. You can verify by this method whether our calculation is correct or not. If u is correct, so definitely v is. And what about c? U is given, it not contains c, so definitely c contains in the v. So this is your required v. Now consider the another example. If u equal to 1 by 2 log of x square plus y square, find its harmonic conjugate v, such that f of z is an analytic function and hence determine f of z in terms of z. So again the same method. Solution is, what is given thing here? U equal to 1 by 2 log of x square plus y square. So differentiate this with respect to x. So it is equal to 1 by 2, 1 upon, what is derivative of log? It is 1 upon x square plus y square, and with respect to x, that is why 2x. So 2 get cancelled. So finally getting here x upon x square plus y square. Similarly, what is dabba u by dabba y? That is equal to 1 by 2, 1 upon x square plus y square into 2y, and that is equal to y upon x square plus y square. So I am getting here dabba u by dabba x equal to x upon x square plus y square, and dabba u by dabba y equal to y upon x square plus y square. So this is equation number 1. We know f dash of z equal to dabba u by dabba x plus I dabba v by dabba x. So now we have dabba u by dabba x. So I want to replace this. So how to replace this? By C.R. equation. Since f of z is analytic function, it satisfies C.R. equations. So which are the C.R. equations? Dabba u by dabba x equal to dabba v by dabba y, and dabba u by dabba y equal to minus dabba v by dabba x. So I want to replace this by this one. So this minus sign this side, so minus dabba u by dabba y. So if this is equation number 2, I can write using this C.R. equations in equation 2, and therefore f dash of z equal to dabba u by dabba x minus I dabba u by dabba y. So both value we have from equation 1, dabba u by dabba x and dabba u by dabba y. So substitute these values here. So f dash of z equal to x upon x square plus y square minus I y upon x square plus y square. Now find this value in terms of z. How? By Milne-Thomson's method. Put x equal to z, y equal to 0, and therefore f dash of z equal to z upon z square plus 0 minus I into 0. So f dash of z equal to 1 by z. So integrating both sides, we get integration of f dash of z with respect to z equal to integration of 1 by z with respect to z plus integration constant c. So that is why f of z equal to log of z plus c. So this is your f of z in terms of z. Now if I want to find a harmonic conjugate v, u is given here. I want to find v. So how to find it? Since z equal to x plus iy. So you remember there, that is the log of x plus iy is what? If you don't know, you must note it. It is 1 by 2 log of real part square plus imaginary part square, means it is x square plus y square plus I tan inverse imaginary by real. So here imaginary is y and the real part is x. So this is the formula for logarithm of complex number plus c as it is. And that is why if we consider f of z equal to u plus iv, so 1 by 2 log of x square plus y square, this is the real part. Here imaginary part is what? Tan inverse y by x. So coefficient of I. So equating real and imaginary parts of both sides. So what it gives? It gives u equal to 1 by 2 log of x square plus y square and v equal to tan inverse y by x. Now you check what is given. If u equal to 1 by 2 log of x square plus y square, so this u is there. So it is correct. It means that this is a required harmonic conjugate. So this plus c, it is not in the given thing. So definitely this c will be here. So this is your required v. Now consider one example on harmonic function. So find the condition under which u equal to ax cube plus bx square y plus cxy square plus dy cube is harmonic function. So what is meant by harmonic function? You know, any solution of Laplace equation is known as harmonic function. It means that dabba square u by dabba x square plus dabba square u by dabba y square equal to 0. So it is harmonic, right? It satisfies this equation. And by using this, we have to find values of a, b, c and d. So what is the solution for this? So given u equal to ax cube plus b square y plus cx y square plus dy cube. So what is the differentiation? Partial differentiation of u with respect to x. It is a dabba u by dabba x equal to. It is a 3ax square plus 2bxy plus cy square. And second derivative with respect to x means differentiate partially with respect to x again. So it gives 6ax plus 2by. Now dabba u by dabba y means differentiation, partial differentiation of u with respect to y. It is first not contains y means 0. Bx square plus 2cxy plus 3dy square. So next derivative with respect to y, it is equal to 2cx plus 6dy. Since u is harmonic function, therefore it satisfies dabba square u by dabba x square plus dabba square u by dabba y square equal to 0. So substitute these values in this equation. So therefore 6ax plus 2by plus 2cx plus 6dy equal to 0. And therefore if we common out x from this, so I am getting here 6a plus 2c x plus remaining y common 2b plus 6d y equal to 0. So what this implies? This implies 6a plus 2c equal to 0 and 2b plus 6d equal to 0. And therefore the relation between this a and c and b and d is A equal to, so divide this by 2. So 3A equal to minus C and B equal to minus 3D. So therefore C equal to minus 3A and B equal to minus 3D. These are the required values or relation between A, B, C, D. Note that here we want to find the condition under which this is harmonic function. So therefore these are two conditions. Under these conditions U is harmonic function. So which is your required answer. Now consider another example, that if f of z equal to u plus iv is an analytic function, find f of z if u minus v equal to x cube plus 3x square y minus 3x y square minus y cube. So note that in this type the relation between u and v is given. It means that the values of u and v. So such type of equations we can solve by again the same thing, that is, you know, f dash of z equal to dabba u by dabba x plus I dabba v by dabba x. So you find both values by this relation. So how to find values of this dabba u by dabba x and dabba v by dabba x? By given relation. So let's see. What is given thing? Given is u minus v equal to x cube plus 3x square y minus 3y square minus y cube. So note that similar method for u plus v, u plus 2v, u equal to 2v, u square equal to 1 by 2v, like that, different relation between u and v. So differentiate this partially. So if we consider this is equation number 1, so with respect to x partially, it is a dabba u by dabba x minus dabba v by dabba x equal to 3x square plus 6xy minus 3y square. Equation number 2. Now again equation 1, differentiate partially with respect to y now. So it gives dabba u by dabba y minus dabba v by dabba y, dabba v by dabba y, that is equal to, so you differentiate this with respect to y now, 3x square minus 6xy minus 3y square. So we have the dabba u by dabba x, dabba v by dabba x, and note that our target contains both, that is f dash of z equal to dabba u by dabba x plus I dabba v by dabba x. This is our target. I want to replace this. How? Again by C.R. equation. So by C.R. equations, since f of z is analytic, it satisfies C.R. equations. Which are the C.R. equations? Dabba u by dabba x equal to dabba v by dabba y and dabba u by dabba y equal to minus dabba v by dabba x. So that is why you replace dabba v by dabba y and dabba u by dabba y in this equation. So this is equation number 3. So using this, in equation 3 we get, so what is dabba u by dabba y? It is minus dabba v by dabba x, and dabba v by dabba y is dabba u by dabba x. So minus as it is, and it is dabba u by dabba x, and that is equal to 3x square minus 6xy minus 3y square. Same thing I can write as dabba u by dabba x, it is minus dabba v by dabba x equal to 3x square minus 6xy minus 3y square. So this is equation number 4. So just observe here, equation 2 contains dabba u by dabba x and dabba v by dabba x. Also equation 4 contains dabba u by dabba x and dabba v by dabba x. So just like a simultaneous equation, find dabba u by dabba x and dabba v by dabba x. So how to find it? That is, we want to cancel this. So if we add equation 2 and 4, so this dabba u by dabba x get cancelled and you will get here value of dabba v by dabba x. Similarly, if we subtract equation 4 from equation 2, this dabba v by dabba x cancel and you will get the value of dabba u by dabba x. So adding equation 2 and 4. Note that what is equation 2? So for reference I am taking this equation 2 here. Okay. So if we adding this equation 2 and 4, I am getting here. So if we add this and this get cancelled, and this minus dabba v by dabba x and this minus dabba v by dabba x. It is a minus 2 times dabba v by dabba x, and that is equal to, so 3x square, it is 6x square, minus 6xy plus 6xy get cancelled, and minus 3y square, it is minus 6y square. If we divide by minus 2, I am getting dabba v by dabba x equal to minus 3x square plus 3y square. This is equation number 5. Now, subtracting equation 4 means here equation 2 minus equation 4. We get, so it will be minus, it means that everywhere sign change, and I am getting here minus 2 times dabba u by dabba x. This minus and plus dabba v by dabba x get cancelled, 3x square minus 3y x square get cancelled, minus 6xy, it is a minus 12xy, and the minus 3y square plus 3y square get cancelled, and therefore I am getting here dabba u by dabba x equal to 6xy. This is equation number 6. Now we have value of dabba v by dabba x and dabba u by dabba x. So therefore, we know f dash of z equal to dabba u by dabba x plus I dabba v by dabba x. Both value we have. What is dabba u by dabba x? It is a 6xy plus I. What is dabba v by dabba x? It is a minus 3x square plus 3y square. It is your f dash of z. I want to find this in the form of z. So by Milne-Thomson's method, put x equal to z and y equal to 0. And therefore f dash of z equal to, it contains y, so 0 plus I minus 3z square plus 0. It means that f dash of z equal to minus 3iz square. So integrating both sides, we get integration of f dash of z with respect to z, that is equal to minus 3i outside. It is a constant z square dz plus integration constant c. And therefore, what is f of z? That is equal to minus 3i and here z cube by 3 plus c. And therefore, what is f of z? Finally, minus I z cube plus c. This is your f of z in terms of z. What we want to find actually? We want to find f of z. So this is your final answer. But if suppose I want to find u and v separately, since z equal to x plus iy, so I can find it. So f of z, it is additional thing I am taking plus c. So it is equal to minus, so cube. So x cube plus 3 x square into iy plus 3x iy square plus iy cube. Note that here I square equal to minus 1 and I cube means I square into I square is minus and I as it is. And that is why f of z equal to minus I outside in bracket x cube plus 3I x square y minus 3xy square and minus iy cube plus c as it is. And that is why f of z, what is f of z? It is a u plus iv, and that is equal to, if we multiply with minus I, so minus I x cube minus, again I into I, it is I square, it is minus 1, so plus 3 x square y minus minus plus I 3 xy square minus minus plus, but again I into I square, so minus minus plus and I square, it is a minus 1 y cube plus c. So what is the real part which not contains I? So 3x square y minus y cube plus I 3xy square minus x cube plus c. So by equating real and imaginary part of both sides, you will get u equal to 3x square y minus y cube and v equal to 3xy square minus x cube. So plus c you can attach to any one. That depends on the conditions. So conditions are not given here. So this is u and v. If we consider u minus v, so what we get? 3x square y minus 3xy square minus y cube minus minus plus x cube. So check here what is u minus v given thing. So this is given thing, u minus v. So whether it is correct? Yes. So your answer is correct one. One more thing you note that the Laplacian operator means what if we define this del square, dabba square by dabba x square plus dabba square by dabba y square is called Laplacian operator, and that is why del square phi equal to dabba square phi by dabba x square plus dabba square phi by dabba y square is called Laplace equation. And here is one relation between this Laplacian operator del square in the form of z and z bar is del square equal to dabba square by dabba x square plus dabba square by dabba y square, that we can express as 4 times dabba square by dabba z bar. Note that this z bar is what? It is a complex conjugate of z. Do you know this complex conjugate means what? If z equal to x plus iy, then z bar equal to x minus iy, known as complex conjugate of z, or you can say the each order. Now one of the another type, that if f of z equal to u plus iv is an analytic function, then prove that dabba square by dabba x square plus dabba square by dabba y square mod of f of z whole square equal to 4 mod of f dash of z whole square. As we know, del square, that is equal to dabba square by dabba x square plus dabba square by dabba y square, and that is equal to 4 dabba square upon dabba z bar. It means that this del square we can express as z and z bar by this relation. So using this relation, so del square equal to 4 dabba square by dabba z bar, we can prove it. So how? So what is the solution? Here dabba square by dabba x square plus dabba square by dabba y square of mod of f of z whole square, and that is equal to, I can write it is a 4 times dabba square by dabba z bar of mod of f of z whole square, and that is equal to 4 as it is. Can I write it is dabba by dabba z of dabba by dabba z bar of this mod of f of z whole square. Note that z into z bar, that is equal to mod of z square. So you should know this relation also, and that is why what is mod of f of z, that is equal to f of z into f of z bar. So same thing I can write as 4 times dabba by dabba z of dabba by dabba z bar of f of z and f of z bar. Note that here differentiation with respect to z bar. So that is why this f of z is constant, which means that z is a constant. So this f of z constant, and what is derivative of this with respect to z bar? It is f dash of z bar. So 4, again here dabba by dabba z of this one, that time this f of z bar is constant. It's a partial derivative, and that is why I am getting here f dash of z and this f dash of z bar as it is. Again by the same relation, f of z bar, that is mod of f of z whole square. So same thing I can write as 4 times mod of f dash of z whole square, and therefore I am getting the relation. What is left hand side? Dabba square by dabba x square plus dabba square by dabba y square of mod of f of z whole square, and that is equal to 4 times mod of f dash of z whole square, which is your required, means so hence proved. So if such type of examples there, you note that z into z bar equal to mod of z square. Another thing is that what is f of z? It is a u plus iv. What is a mod of f of z? It is equal to under root of u square plus v square. Also you should know u is a real part of f of z. It means that I can write real of f of z, that is equal to u, and imaginary of f of z, that is equal to v. So these relations you remember, because maybe the examples of this type of along with this and such type of different relations. Now consider one more example on similar type, that is if f of z equal to u plus iv is an analytic function, then prove that dabba square by dabba x square plus dabba square by dabba y square of mod of real of f of z whole square, that is equal to 2 times mod of f dash of z whole square. Now the solution of this, since we know dabba square upon dabba x square plus dabba square upon dabba y square equal to 4 times dabba square upon dabba z bar. Now what is given thing? It is f dash of z. Since what is f of z? F of z equal to u plus iv. So real part of f of z. that is equal to u. And what is the f dash of z? That is equal to dabba u by dabba x plus I dabba v by dabba x. And therefore, mod of f dash of z whole square, that is equal to mod of dabba u by dabba x plus I dabba v by dabba y whole square. And that you know, it is a mod of z means mod of x plus iy, that is equal to under root of real part square plus imaginary part square. So here I am getting it is the under root of dabba u by dabba x, which is the real part whole square, plus dabba v by dabba x whole square and whole thing square. Therefore, mod of f dash of z whole square equal to dabba u by dabba x whole square plus dabba v by dabba x whole square. This is your right hand side. So this part is there. Note that. So I will denote this is equation number 1. Now by the relation, that is the dabba square by dabba x square, left hand side I am taking dabba square by dabba y square of mod of real part of f of z whole square, and that is I am getting dabba square by dabba x square plus dabba square by dabba y square. What is the real part of this? It is the u square. So that is equal to dabba by dabba x, dabba by dabba x of u square plus dabba by dabba y, dabba by dabba y of u square. So what is this one? So what is the derivative with respect to x? So I am getting it is a 2u dabba u by dabba x plus dabba by dabba y, and it is a 2u dabba u by dabba y. So 2 common, and I am getting here 2 in bracket. What about this 2? It is a dabba u by dabba x into dabba u by dabba x plus dabba u by dabba y into dabba u by dabba y. So same thing I can write, it is a 2 times dabba u by dabba x whole square plus dabba u by dabba y whole square. So from equation 1, what is dabba u by dabba x whole square plus dabba v by dabba x whole square, that is equal to mod of f dash of z whole square. So I can write here, so from equation 1, this is equal to 2 as it is, and this is a mod of f dash of z whole square. What is the left hand side here? It is a dabba square by dabba x square plus dabba square by dabba y square of a real of f of z whole square, which is your final, means hence proved.